This video is on composition of functions. This is hopefully going to help you a little bit on your homeworks. So with function notation, you have to remember that f of x equals y. And the reason we do that is because we don't always graph functions. Sometimes we have to name them, and this gives us a way to name them. So the function's name is f. We use x and y in the graphs, or to graph it as for an ordered pair. And so if I did f of 2, what does that mean? Well, if you look above, what changed in our notation? The x value became 2. So this means find y when x is 2. And then if I did f of x equals 2, this one, if you follow, the f of x is the same, the y became 2. So this means find x when y is 2. Well, in composition of functions, we're going to be dealing with this part. We're plugging something in, but instead of just being a constant, we're going to be plugging in an equation. So look at this example. If we have f of x is 2x plus 3 and g of x is x plus 1, they want us to find fog of x. Well, f, composition of g of x, is the same as writing f of g of x. And what that means, if you put the f of x above it, it means every x value in f, we plug in the g equation. So on this one, f of g of x, we're going to look at g of x, and which is x minus 1. And everywhere we see an x in f, we're going to plug in the x minus 1. So we're going to start 2, then times x minus 1, and then plus 3. And then you simplify this. If you have a number in front of the parentheses, you distribute. So 2x minus 2 plus 3. Combine like terms. Well, negative 2 plus 3 is 1. So we get 2x plus 1. And then that is our final answer because we input g into f. Okay. On this one, we're doing the same thing. F of g of x. So we're taking g of x, so we're taking 3x plus 2 and plugging it into x squared. So we're just going to have 3x plus 2 squared. Now, a lot of times they're okay with this. You don't have to simplify it. But if you do and you don't remember how to deal with the squareds, remember what an exponent means. It means you have 2 of these. So this becomes or equals 3x plus 2 times 3x plus 2. And I'm not sure how you've multiplied binomials. Normally, most people either use FOIL or they double distribute. I just look at the first term and multiply it by everything in the second part. So 3x times 3x is 9x squared. 3x times 2 is 6x. 2 times 3x is 6x. And 2 times 2 is 4. Combine like terms, and so we end up with 9x squared plus 12x, because 6 and 6 is 12, plus 4. And then that is the other answer. Most of the time, if this is above a 2, if it's cubed, or if it's to the 4th power, don't simplify it. Just leave it like this. Okay. On this one, it changed on us. Notice, and I underlined it in red so I would remember, it changed it. Instead of f of g, they want g of f. So our notation would be g of f of x. So it's telling us wherever we see x in g over here, we're going to plug in 1 over x. So we're going to get 1 over x plus 4. That's as simple as we can do that. We can't make that equation any better. So we have a denominator though. And remember in our domain restrictions, we can't have a square root or a denominator. And so in this case, we set our denominator not equal to 0. So x can't be equal to 0. All right. This one wants f of g of x. So we went backward to the other way. And you have to look at it to see which one they want you to plug in. So everywhere in f, every x, we're going to plug in 2x. So I end up with 2x plus 1 over 2x minus 2. I can't simplify this. Even if I factor the 2 out in this one, I'm still going to have x minus 1. So there's nothing I can do to help myself here. So I'm just going to leave it like this. Instead of writing out domain restriction, I'm going to write dr just to save a little bit of time. So our domain restriction, the denominator can't be 0. So 2x minus 2 can't be 0. And then you solve that. Add 2. 2x can't be 2. And then divide by 2. So x can't be 1. All right, on our last one, f of g of x. This is 1 over x. I know it looks a little funny. I think it's just the way my equation imported, but it just means 1 over x. So we're going to plug in 2x minus 1 over x plus 5 into this equation here, into our f. So we keep our 1. Then we're going to change x to all of this. So 2x minus 1 over x plus 5. And if you remember back when you were dividing fractions, you always had to keep your first one, change your second one to multiply, and flip the second number or second fraction, second division. So this becomes 1 times, and then we're going to flip this. So we're going to keep this one, change it to multiply, and flip this one. So it's going to be x plus 5 over 2x minus 1. And then 1 times that is just x plus 5 because 1 changes nothing, 2x minus 1. Our domain restriction would be 2x minus 1 can't be 0. Add 1, 2x can't be 1. Divide by 2, so x can't be 1/2. Hopefully this helps a little bit on composition of functions.